Okay, today our topic is to learn about the first order differential equations. We have already learned the first part of this equation, that is first order differential equation. First order differential equation, that is the topic we were discussing in the last session. So, for example, the questions what we have learned here is if it is dy by dx equals to like x or y squared or something. What you need to do is you have to take x terms to one side and y squared to y terms to other side. Dy equals to x dx. Then after that, we just integrated y squared dy is equals to integration of x dx. Right. So this is done up to y cube over 3 is equals to x squared over 2 plus c. Sometimes they might give you some kind of a point it travels to. With that, you can obtain this answer. So it's done up to 3 cube, sorry, it's done up to 2 cube over 3 is equals to 1 squared over 2 plus c. Therefore, c become 8 over 3 minus 1 over 3, 1 over 2. Okay, so it's done up to 16 minus 3 is 13 over 6. With that, you can write the differential equation. Y cube over 3 is equals to x squared over 2 plus 16 over 6. Sorry, 13 over 6. If you want, you can multiply everything with 6 and after that you can subtracting y. You can do it. That was the sections where we have learned in the last class, the last first order differential equations topic day. Right. Now today we need to start with the next extension of this first order differential equations. That means this is the formation. Right. Yeah. The format today, what we need to learn here is this is a format. That is dy. That is dy by dx plus py is equals to some kind of a function equals to q, where p and q are functions of x. Yeah, functions, it's just like function, not x. Right. Okay. That's a format where we have to learn. Right. Okay. Let's come up with one example and try to understand how it comes to this. Look at this. Then this is x cube dy by dx plus 3x squared y is equals to sine x. When I make it, we use one supporting format of doing this question. For example, if you differentiate this, I'll get some example for that. If you differentiate x cube y, what would be that answer there? Keep x cube and differentiation of y is dy by dx plus keep y, differentiation of x cube is 3x squared, which is literally same thing as this. Is literally same thing as this. Therefore, instead of this bit, I can write d by dx of x cube y is equals to sine x. Equals to sine x, right? Okay. Then what you can do here is in the next step, integrate the both sides to them. X cube y is equals to integration of sine x to them. Then you can say this whole function is differentiated and then integrated. Whole function is differentiated and integrated means what happened with it? This integration cancel out with the differentiation. So simply it's turned up into x cube y is equal to sine x integration is minus cos x. Then you can say plus c. Then you can write y equals to minus cos x plus c divided by x cube. That's the final answer for that. Later on, sometimes they might give you some extensions to find the answers for this c value. So other than that, there is a way of doing it. But yeah, But the problem where we come across is just looking at this answer, how can we analyze this? How to understand this fact? That is the main problem. But just because when I'm explaining, yeah, okay, this is what, so you can just write it. But just looking at a question, how do we verify this? That's a fact we have to understand, right? Okay, this is the way of doing it. I'll erase this. Now, when you happen to see such question, initially see whether this part of it. Isolate this dy by dx. Right. Isolated this y terms, dy by dx, so down with y terms, and see whether the other term, differentiate and see whether can you get that answer over here. Isolate dy by dx along with the y terms, and if you remove that part of the expression, the remaining part, see whether the differentiation can be isolated over here. Yes, it's there. Then if you isolate that one, there is another part remain over here. See whether the differentiation of that is over here. Yes, that is correct. Then in that case, what you need to do is select this part from this one and select this one from the other side of it. Then you can write it as this is as a complete differentiation of this equals to sin x. After that, you can follow up the same technique over here. But the next extension is, if this is not how we supposed to do, later on we will understand such situation, right? For the moment, that is how it comes. Okay. Then if you move up to a question like this, dy by dx is dy by dx plus 3y plus 3y over x is equals to sin x over x cube, right? Then over here, that if you isolate this term, the remaining term is 1 today. There are the differentiation you cannot see over here, and that problem is there. So with that, I'll use a small trick for this. I can see like this x cube is like integration of the sin x over x cube is a little bit literally not much confident enough to do that some kind of integration. Therefore, I'll multiply entire expression by x cube. Sorry, I'll multiply entire expression by x cube. Multiply with x cube, all the terms. In that case, what do you get for this? X cube dy by dx plus 3y x squared is equals to sin x. Right. Now you have some kind of expression for it. Now see whether the differentiation of this is available here. Yes, you can get it from here. This part is there. That means I will get x cube from this side. Then the remaining term is this bit. See whether the differentiation is available there. Yeah. So you can just write it. Then you can write this is d by dx of that equals to sin x. Then what you can do, integrate the both sides. Integration of d by dx of x cube y is equals to integration of sin x. With that you can say integration, total integration, cancel out with total differentiation. With that it cancel over here. So you can write this is x cube y is equals to minus cos x plus c. With that you can say y equals to minus cos x plus c divided by x cube. That's the same thing what you obtained in the previous thing, because it's the next extension of the question. Right. Okay. Now let's move to the next question. Then the next part of it. Right. Then this is called the integrating factor. Next theory is called the integrating factor. For example, yeah, අපි යම් බලන්න මේ question එක. So before we come up with integrating factor, let's come to this part of it. Right. You get x dy by dx plus y is equals to cos x. Now see whether differentiation of this is available here. Yes, it's there. So you can just write this is dy by dx into 1. Yeah. So x you can isolate. Then the other term is here. So it's a differentiation there. Yeah, that's all. Therefore, you can write it's the differentiation of xy is equals to cos x. Then integrate the both sides. Integration and differentiation get cancelled over here. Xy is equals to sin x. Therefore, you can say y plus c. Therefore, you can say this is sin x plus c over x cube. That's how it comes. Right. Then I'll erase it. Then if you move to the next question, this is e to the power minus x dy by dx minus e to the power minus xy is equals to x e to the power x e to the power x. Yeah. When we supposed to do this question, so what you can get here is this. I'll show you how to do this integration later on. After the integration, we will learn how it exactly it happens today. So anyway, what you can do is you can get see whether e to the power x differentiation is here. Yeah, it's here. This part of. Therefore, you can select e to the power minus x. Then the remaining term is this. See whether the differentiation is there. Then you can write this is all differentiation of this. Is equals to x e to the power x. Then integrate the both sides. Dx e to the power minus xy is equals to integration of x e to the power x. Right. Then what you can get here is this whole thing get cancels with that. So it's turn up to e to the power minus xy is equals to integration of x e to the power x. We are using some kind of a rule called integration by parts. Later on, after the integration, we will learn how it comes. I will just do it and show you. After learning the integration by parts, you will get that how you get this answer. Right? For the moment, just copy down this one. Later on, we by another within this week or next week, we'll be finishing that part in the integration as well. So what you need to do is, I'll just do the integration and show you. But just don't worry about it. We will learn this one in another, within 2 weeks, we will be finishing this section. If it happens, you can write this is x e to the power x. This is, you can say u equals to x. And therefore, du by dx is equals to 1. dv by dx equals to, I just forgot about this part. And I'm just showing the steps only. X e to the power x minus integration by e to the power x into 1 dx. So x e to the power x minus e to the power x is the answer. Therefore, you can say this part e to the power minus xy is equals to x e to the power x minus e to the power x. Therefore, it's turned up to x e to the power x minus e to the power x divided by e to the power minus x. So if you brought it out, e to the power x, e to the power 2x, now make it, this is turned up to x minus 1 plus c. You can write the final answer with that. That's the way of doing the answer. Right. Okay, later on, don't worry about this part, how we did it. Just up down. Later on, after they will doing the entire integration topic, we will understand that how we get these answers. Right? Okay. Yes, but then, okay, let's go to the next part. Okay. The next part of this integration is just like this. Right. If you happen to find some question like this, we call the integration factor. Integrating factor. Integrating factor means, Pute, if you happen to find a question like this, dy by dx plus py is equals to q, where p and q are functions, right? So if it's so, Pute, what we need to do is we define an integrating factor like this. Integrating factor, we consider e to the power integration of p dx, the function which is adjoined with y term. That is what you mean by integrating factor. If you happen to find this kind of a question, Pute, multiply all of these terms by integrating factor. That's a theory of doing this question, right? If you happen to see a question like this, what you need to do is multiply all of the term by integrating factor. Equation 1 multiply equation by integrating factor. Then it turns to form d by dx of fx into gx is equals to kx format. So that's what you did in the previous section, right? That is a theory where we need to understand. From a question, let's try to understand what do you mean by this conversion form and all of these things, right? Yes, right. Fadil, is that clear for the
shapes?
shape, right? Okay, question I don't know how it comes, right? It's not that hard. Look at this. Right. For this case, you can, so initially I'll just write the format of it. Then it would be giving you some kind of extra help to understand the question. d by dx plus py equals to q, right? Now the logic is like this, the first example. dy by dx minus 4y is equals to e to the power x, right? Now, the first concept when you are working out with this question, see whether the differentiation of this number available here and if you remove that part from this expression, that differentiation is available here. So the term over here is how much? It's 1. The term here is 1. 1. But the differentiation of 1 is not available here. Therefore, you cannot use the previous format where we were working out to do this kind of question. So I had to omit this part of it. Then you have to use this technique. To apply this technique today, the most important point is this term should be 1. That is compulsory. So it's obviously it's 1. It's not a problem. Then we'll try to find out. Then what we need to do is in this way. This is the integrating factor. Therefore, you can write IF, integrating factor. Integrating factor is e to the power integration of p. P is minus 4. This is the point where we have to understand. So, if you integrate e to the power, e to the power, if you integrate minus 4, what would be the answer? This is turned up to minus 4x. We won't put plus c at the end, so you just write e to the power minus 4x. Then multiply all of these expression by e to the power minus 4x. Then what happens? Then this expression turns to this format. E to the power minus 4x.
So what happened to the d?
Over there?
Integrate minus 4 dx, no? Up.
Integrate?
The power?
Yeah, power. Integration of minus 4x is how much? We have to integrate only this bit. Integration of minus 4 is minus 4x. The answer is this. Integrating factor is this. Integrating factor is e to the power integration of fx. For example, integration factor e to the power 3x, 3dx. Answer is e to the power 3x. If this is integrating factor is e to the power integration of x squared dx, what would be the answer? E to the power x cube over 3. It's not integration of e, it's a integration, e to the power integration of function. You just write integration of function, write it over here. Is that clear for that?
Yes.
Yeah, that's great. Okay. Not a problem. I'll explain it again from the beginning. Right. Then put this part of it. Then minus 4y e to the power minus 4x is equals to e to the power x times of e to the power minus 4x. Now see whether this part. Now see whether this part of it. This is pretty interesting. That's what I was mentioning. Like yes, it happens, right? So over here, the integration of this. What is the integration of minus 4x? It's over here. It's over here. Therefore, I can get that part as a one part of it. Right. Then what is the remaining term? Remaining term is this bit. Make. Now see that the differentiation of this is available here. Yeah, it's there. Then you can write y over there. Right. Then you can say this is d by dx of that times is equals to e to the power x e to the power minus 4x is to the e to the power minus 3x. When you multiply, you can add the powers. Right. Then you can integrate the both sides with it. d by dx of e to the power minus 4xy is equals to integration of e to the power minus 3x. Then, what is the concept? You can cancel this integration with this differentiation with integration. So, it turns to a fact like this. E to the power minus 4xy, e to the power minus 3x integration is for the e to the power minus 3x divided by minus 3 plus c. Yeah. Then I write the rest of it today. Y equals to minus 1 over 3 e to the power minus 3x plus c whole thing divided by e to the power minus 4x. If you want, you can write the answer in this format. Y equals to minus 1 over 3 e to the power minus 6 divided by minus 4x is x plus c e to the power 4x on a major and I will just keep this format even enough. Later on, it depends on the way they ask this question. That's a way of getting this answer. Okay, let's move to the next question. Right. Then it's like this. Cos x dy by dx plus 2y sin x equals to cos to the power 4x. Now see whether the differentiation of this is available here. Cos x differentiation is minus sin x. There is and the remaining term is 2y from the differentiation over here. So that approach won't applicable for this question. Right. Then what is the next option where we can go ahead with that? Right. Then you have used it. Sorry, what is it for?
No.
Yeah. Then we have to come up to this format. To come up to this format, this number should be 1. That is essential. That is an essential step. Right. Other than that, you will put this integration factor of that. Then divide the entire expression by cos x. Then what happens? Dy by dx plus 2y. This is turned up to how much? Tan x is equals to cos cube x. See whether can you understand how I get this step? Right. Then we need to identify what is the integration factor, IF. Integrating factor. That is e to the power integration. If you isolate y, the remaining term is what? What is the remaining term? The remaining term is 2 tan x. Make it the integrating factor. Then this one. 2 tan x is the one. Right. Then e to the power 2 tan x. If you integrate tan x, answer is this one. So we have already learned that 2 ln sec x. In that integration formats, we have already learned how to integrate ln tan x. Right. Then how to simplify this? But I'm going to simplify a little bit over here. E to the power 2 ln sec x. Then I can take this 2 input there. That is ln. If you take this 2 in, this is turned up to sec squared x. Sec squared x. Right. Then what happens to it? If e and ln get cancelled and turn up to just sec squared x, then integrating factor become, if you simplify this is turned up to just sec squared x. Then multiply entire expression by sec squared x. See whether what happened to it. This is sec squared x dy by dx plus 2y sec squared x tan x is equals to cos cube x multiplied by sec squared x is cos cube x multiplied by sec squared x. Right. Then what happened to this? Now see whether this part of it. Differentiation of sec squared x. You just differentiate, you will understand that it will turn up to this figure. Just differentiate and see whether you get this answer. Not a problem. Definitely it happens to them. Right. Then difference. So you can write this part of it. One part is sec squared x. Right. Then the other part is this big. Yeah, it's over here. So it's the other part is y. This is d by dx of sec squared y. It's equals to cos sec, sorry, sec squared x is 1 of cos squared x turn up to cos x. Then I'll integrate the both sides. So what you get? This is turn up to sec squared xy is equals to integration of cos x is for the sin x. Then you can say sin x plus c over sec squared x would be the answer for y. That's a way of getting that answer, right? Yeah, that's a way of getting this kind of integrating factors, right? Then basically you have this this format. So initially you have to understand this concept, and we will go ahead with the sections based on this as a future question, because basically we need a little bit of a more knowledge in integration that is kind of supporting for us to do the rest of the sessions.
That's all for today.